Hey, what's going on, guys? Welcome back to the channel, and I hope you're having a good morning. In today's video, I kind of want to talk about a pretty common question that I get on this channel here. And the question is whether or not it's, important to be good at math if you're trying to become a software engineer or a software developer. So my official kind of stance on this topic is that I think it's pretty important that you are comfortable with dealing with numbers and also dealing with basic geometry. And this is especially important if you're trying to become an iOS engineer, Android developer, or even a web application developer. And so the reason why this is important is because every time you're dealing with rendering out something onto the screen, you always have to deal with layout and then basic geometry so that you can fit the entire layout into whatever specific dimension size you're working with. So right now, I'm going to show you a very basic example of where I've had to use math to kind of deal with layout. All right, so what you are seeing on the screen right now is a live recording of my iPad down here, and I've loaded it onto the home screen of an application called Touch of Modern, and I worked on this app for about a year and a half or so. And the home screen has a 3-column layout that kind of looks like this as I scroll up and down, right? And so when you rotate the device to a portrait orientation, it kind of redraws the layout into a 2-column grid like this. So if you rotate it back, it then switches to the 3-column layout instead. And so this kind of relaying out of the grid deals with the horizontal space that is available to us, and also the amount of cells that we can place onto that horizontal plane. So a lot of geometry there is pretty basic, but it's important that you kind of understand how that works. Another example I want to show you is if I want to click into this watch right here and then load up one of these watch products, you see how I have a lot of images on the top row, right? So if I click on one of these images, it zooms into the middle of the device. So some math is involved to kind of calculate where the center point is. If I scroll over to perhaps the last image on this kind of carousel here, and I hit the done button on the top right, it'll zoom the image back to its original kind of frame that is all the way on the right. So some math is kind of required for it to know where to exactly zoom back on. Okay, so here is a more sophisticated example of the application of mathematics inside of software development. What you see on the screen right now is just basic Google Maps, and we are located inside of Mountain View, Sunnyvale, basically the South Bay of the entire Bay Area. Now, when I first graduated out of college, I worked at a company where I had to deal with drawing maps kind of very similar to Google Maps right here. And the way that these mapping systems kind of work is that you're provided with a lot of data points in terms of what you have to render into the mapping system. And these data points kind of render out things like the airport right here, these parks, and also a lot of these roads, these highways, and these city names right here. And in addition to all of that, when you're rendering out these maps, you have to deal with something called zoom levels. And if you zoom in and zoom out like that, you can kind of see the stitching of the entire map through kind of a tile system. As I zoom in, you kind of see more detailed tiles as you dive deeper into the map there. And so the thing about these mapping systems is that you have to do a lot of math to render all of these items based on the latitude and longitude values of these objects. And once you are kind of done rendering out what we call these tiles of the map, you have to stitch them together so that you can kind of request for them as you pan around in the map. Now you can see that effect a little bit better when your connection is a little slower. The map renders a little bit choppier, and you can kind of see the blocks and the tiles rendering out as you are panning across the map. All right, so finally, the last example I want to give you here comes from an article that talks about the city of Austin, Texas. And inside of the city here, Uber and Lyft, these ride-sharing services, are not available due to these companies not wanting to follow compliance rules from the government. So essentially, in place of these two juggernaut companies are smaller ride-sharing services, right? And basically, the article outlines this problem that these services have whenever demand for car sharing services rise up and surge to 10 times what the normal expectations are. And so what this led to was the application eventually just crashed and stopped working, and a lot of the drivers just couldn't match up to potential passengers that needed to get to point A to point B. Okay, so what does this problem have to do with mathematics, you're probably asking? Well, the problem essentially lies inside of scalability and the lack of a proper solution when it comes to a huge surge in users for your application. I think these companies that are providing these ride-sharing services should have probably done a better job at modeling what would the impact of all of these users be when it comes to peak hours. Okay, so that's going to be it for today's video. Hopefully you found this information helpful, and I kind of want to know what examples you've ran into where you've had to deal with mathematics inside of programming as well. All right, and make sure you don't forget to like and subscribe to the channel if you haven't done so already. Hopefully I'll see you in the next video. Bye-bye, guys.